All right, so in this video, we're going to review random variables and probability distributions. All of this you should have seen in some of your previous classes. We already talked about some of it anyway. All right, so a probability distribution specifies the probabilities of all possible outcomes of a random variable. So we're going to talk about probability distributions. So it's a probability distribution specifies the probabilities of the possible outcomes of a random variable. A random variable is a quantity whose future outcomes are uncertain or unknown. So probability distribution for a dice, for instance, would be you have one, you can roll 1 through 6. It's integers, and each one is uniformly distributed. So it's each one has a probability of 1 over 6. A random variable may be discrete. So discrete random variable. Discrete means that it would be discrete if it's countable. If countable. This is very important. So a discrete random variable could be dice like before. It could be customer arrivals at a store. So the number of customers, it's countable. It could be 0. It could be infinite, but it's still countable. It's still an integer. It's a number that you can count. It could be the number of cars sold in a given year, in a given month, or even a given day. Those are discrete. They're countable. That's very important. Discrete is countable. A random variable may also be continuous. So continuous. So if an example of a continuous random variable, it's not countable. So continuous would mean that it is not countable. So it could be all real numbers. An example of continuous could be portfolio returns. A portfolio return could be 0.01%. It could be 0.101%. It's not countable. It's time is another example of not countable. So change in stock price, distances, time, maybe the time that someone spends in a store or on a car lot, it's not countable. It's continuous. So every random variable, whether it's discrete or continuous, is associated with a probability distribution that describes the variable completely. So for a let's do discrete. Let's say for a discrete random variable, discrete random variables. Discrete random variables. Discrete random variables follow a probability function or a probability mass function. I'll just say PF or probability function. This specifies the probability that the random variable takes a value, takes a very specific value. So maybe if you're doing a car lot, or let's say X is the number of cars sold per month. Let's say the probability of let's say the probability of 5 cars sold in a month, that'd be the probability of X, big X, being equal to 5. This is going to be equal to some probability. It's going to be a number between 0 and 1. So the probability of big X being equal to a little x. So X is the random variable. X would be the value. This is going to be between 0 and 1. This comes back from the rules of probability. So for any probability, it has to be between 0 and 1. And for a continuous random variable, for a continuous, say RV for random variable, they follow a probability density function. So for a probability density function, for this, it typically has to be a range. So let's say you can't really say your portfolio return is going to be exactly 2.03%, but you could say what's the probability that you're going to have portfolio returns between maybe 2% and and 2.5%. You could have a range. So for a continuous random variable, you can have a range of values. So the probability that your portfolio will have a return between 2 and 2.5%. So this is random variable and probability functions. In our next video, we're going to do probability function properties. We're going to talk a little bit more about distributions and cumulative distributions, and we'll do an example.